let's go ahead and review what we spoke about in terms of those lung volumes and lung capacities and sort of illustrate that to make it a little bit clearer here. So let's start by doing the lung volumes first, and then we'll do a separate graph for the lung capacities. All right, and as I kind of draw this here, just to remind ourselves of the main difference between a lung volume and a lung capacity. A lung volume is going to be directly measured, from the spirometer. So it's going to be immediately measured from the spirometer. And so those are going to be what we read or what we ask the patient to inhale and exhale, and we can read on that machine. The capacities are what we deduce based upon those readings, okay? So the capacities are not fixed readings. They're basically the addition of 2 or more lung volumes, okay? So just to clarify the difference there, and then we'll get into this graph with the lung volumes. So I'm just making some benchmarks here for our different lung volumes, and then we'll draw these curves in. So we start out with our volume here. That's the amount of air being moved. Oops. Our volumes here on the Y. Milliliters. And then our time on the X. Okay. And so the first volume that we're going to draw in here is our tidal volume. And again, I encourage you as we do this to think about these volumes on yourself, right? Actually manipulating your respiration in order to observe some of these volumes. So the first one we start with is your normal quiet respiration. This is called your tidal volume. Okay, so if you're taking a nice, normal, rested breath, this is the amount of volume that you're moving in and out, okay? And I'm not gonna put any numbers in here. This is really just for reference in terms of these volumes, differentiating them from each other. So we've got our resting volume, which is our tidal volume, all right? And I'm gonna put a little key up in the corner here. Oops, so this is V and a T, and then this is representing tidal volume. Okay, now remember, tidal volume includes both that quiet inspiration and that quiet expiration. All right, so in either direction. And then I'm also going to label here that this is a quiet, normal breath. All right, our tidal volume. The next volume that we'll look at is the inspiratory reserve volume. Okay, the inspiratory reserve volume. Let's use another color here. Okay, so our inspiratory reserve volume is the amount of air that we can inspire on top of our tidal volume. So we're not going to include tidal volume. It's going to be the amount of air we can breathe in on top of our tidal volume. So just this bit here. Okay, and again, this is going to be a forced inspiration. So if you're breathing quietly and then you try to bring more air in a forced way, really calling on the diaphragm to flatten out those intercostals to contract and open up the rib cage, that is going to be your inspiratory reserve volume. Okay, so that'll be IRV, the inspiratory reserve volume. And so we're going to label this curve as maximum inspiration. Maximum or forced is another word you can put there. Okay, and this is your IRV. Okay, let's think about that in the opposite direction. So our expiratory reserve volume is going to be the amount of air that we can force out beyond our tidal volume. Okay, so again, thinking about this curve in the opposite direction, if I can take a quiet, normal breath out and then force more air out on top of that, that is my expiratory reserve volume. All right. So again, not inclusive of tidal volume, just the addition on top of tidal volume here. So this is our expiratory reserve volume. Oops. Okay, and then we'll label this curve here. This is going to be our maximum or forced expiration. And then our final lung volume is one that we cannot measure with a spirometer. Okay, it's going to be what always remains in the lungs. And I talked about this being one that we measure using helium dilution. All right, this is going to be our residual volume. So what is always left back in the lungs is our residual volume. Okay. In brackets, I'm going to put not directly measured. Right. Okay, so everyone clear so far in terms of these basic lung volumes, right? These are immediate measurements that we can take from the spirometer by having a patient inhale or exhale, blowing into that tube, and then we can measure these volumes, accepting residual volume. And then from these volumes, we can then deduce the capacities that we're going to talk about here in a second. Okay. All right, so any questions on this before we move along? And be comfortable with this in terms of your exam. Make sure that you are comfortable looking at a graph, deducing the difference between tidal volume, inspiratory reserve. If I give you one large curve such as this and I ask you about inspiratory reserve, you should be able to subtract the entire length of the curve, right? If I give you this reading, subtract tidal volume, and that would be how you would calculate your inspiratory reserve. So again, be comfortable doing that in terms of looking at a graph, deducing these different curves, and then calculating based upon given values. And we'll practice some of that too, so stay tuned. Okay, so now let's kind of shift gears here and look at the lung capacity. So these are the volumes that we can deduce by combining two or more lung volumes. So these are our lung capacities. So I'm going to create a similar sort of outline here. I'm going to make this just a little bigger, actually. Hang on here. Okay. Clean this out just a bit so we can put our key over here, and then we'll start with our lung capacities here. So again, we're thinking about tidal volume being that normal, quiet breath, right? We go in and out in a normal, quiet breath. And then we want to think about a max inspiration or a forced inspiration here. Okay. So this is a normal breath. And this is max inspiration. Okay, and so based on that, we are going to add our tidal volume to our inspiratory reserve, and that is our inspiratory capacity. Okay, so let's put this in one color here. So our inspiratory reserve, which is this, our tidal volume, which is this, and we combine those two as our inspiratory capacity. So IRV plus tidal volume, and then both of these is our inspiratory capacity. Okay. And let's just make a little key in the upper corner here. So inspiratory capacity is equal to tidal volume plus our inspiratory reserve volume. All right, I'm actually going to write the words out just so we. Okay, so that's our first lung capacity. It's our tidal volume plus our inspiratory reserve. Let's look at our vital capacity. So our vital capacity is going to be most of our lung volumes, all of our movable lung volumes. So that's going to be tidal volume, inspiratory reserve, and expiratory reserve. So if you think about a, let's do this. So curve down here. It's going to be our max inspiration all the way down to our max expiration. Okay, so this is max expiration. And so we're including our inspiratory reserve. So this is inspiratory reserve. We're including our tidal volume. We're also, tidal volume. We're also including our expiratory reserve, right? So all of this, expiratory reserve. And so all of that, all three of these volumes is our vital capacity. Okay, so I'll put up here in our little key vital capacity. Is our tidal volume plus our inspiratory reserve plus our expiratory reserve. Okay, I hope that's clear there. All right, and then the final capacity is going to be our forced residual capacity. That's going to be all of our air that's left after quiet respiration. So after you take, let's change our color here. After you take a quiet breath out, so this is our quiet breath in and out here, whatever's left in the lung beyond this point is going to be our forced residual capacity. And so that's going to include our residual volume as well. So our residual volume plus our expiratory reserve volume. And then both of these, right, both of these volumes here is our our functional residual capacity. Okay. And again, let's put our little key here. I wish I made more space at the top. But in brackets here, our functional residual capacity, FRC, equals our expiratory reserve volume and our residual volume. Okay. All right, so these are our lung capacities. And then the final one is just a combination of all of these lung volumes. So if we take into account the most forced inspiration along with the most forced expiration, as well as residual volume, all of that, so all of these capacities, all of these volumes is our total lung capacity, right? Inclusive of residual volume down here. So residual volume, expiratory reserve volume, tidal volume, inspiratory reserve volume, all of that makes up our total lung capacity, okay? And I don't have much space over here, so I'm gonna bring that to the bottom here. So our total lung capacity where TLC is residual volume plus tidal volume plus inspiratory reserve plus expiratory reserve, okay? And another way to think about this is residual volume plus vital capacities. Remember, all of this is vital capacity, okay? And that is our total lung capacity. And I just realized I forgot to put my labels here. So this is volume again in milliliters. And then we've got time down here in seconds. Okay, so our inspiratory capacity, tidal volume plus the additional inspiratory reserve, vital capacity being all of our movable volumes. So tidal volume, forced inspiration, which is inspiratory reserve, forced expiration, which is expiratory reserve, and our functional residual capacity being all of our air that's left in after a quiet breath. So expiratory reserve, which is the amount that we could force out if we tried, along with residual volume, which we can never force out. And then our total lung capacity is a combination of all of those lung volumes.